Good morning, this is Miss Malatin, and today we're going to learn how to identify types of reactions. We are going to use the North Carolina Chemistry Reference Table as a guideline, and later on, after we've learned how to identify types, we will be able to predict the products of chemical reactions based on the reactants. So the first one we're going to look at is synthesis, coming from the word synthesis, like synthesize, bring together, to form. So our basic model is A plus B equals AB. So I have labeled these. A single element, plus B, when they react together, that's what this plus sign means, yields or produces, there's several words for it, a binary compound. We want to note that the subscripts are not the same. The bonds in the reactants break and reform into the products according to the rules of bonding that we learned in the last chapter. And this is called a synthesis reaction. And right there, synthesis, like synthesize, come together. And my big key is that there's one product. This is the only one of the reactions, the binary synthesis. There's one product. The next type we'll look at is binary decomposition, where we have a compound, a binary compound, and we can label these, that decomposes, like a body decomposes. So one reactant and two products. This is something breaking down. You usually have to add energy, and this is one reactant. Now, if you look, there's many types, but the one thing we can always recognize these because there is one reactant. So in this case, we're going to look at single replacement, and our first example will be metal-to-metal replacement. How I recognize these is we have a single metal by itself, an ionic compound, and then that single metal replaces the metal. It can only replace the metal in the ionic compound, so it goes with the nonmetal from the compound, and then the metal from the reactant ionic compound is by itself. So this is zinc reacts with copper chloride to produce zinc chloride and copper. The one thing we need to make sure of, so zinc is replacing copper. On page 7, you have your activity series of metals. We need to make sure that zinc is more active than copper. It will not replace copper if it is not more active. So copper is way down here, and zinc is up here. The higher you are on the activity series, the more active. So since zinc is above copper, this reaction will happen. So this is A plus BC yields AC plus B. The next type of single replacement reaction that we will look at is called halide-halide, and that's from the halogens. And basically this is a nonmetal replacing a nonmetal. So it's anion or nonmetal replacement. So we have a single halide by itself. We have bromine gas. It's a diatomic molecule, so we know it's Br2. Reacts with potassium iodide, and that's a nonmetal, to produce potassium bromide. You notice we don't have the same subscripts. We have broken the bonds and reforming them according to the laws of bonding, and iodine gas. The bromine can only go into the nonmetal spot. We also have to check to make sure that bromine is more active than iodine. And on page 7, we have the activity series of halogen. And the higher you are, the more reactive, and bromine is higher than iodine. So these are only the single replacement reactions that we have to check these. I also want to make sure to know most of these that we're looking at have not been balanced. This one is, but they've not been balanced yet most of the time. So that is single replacement. We're going on to the double replacement reaction. The best way to recognize these is we have two compounds. In our single replacement, there was a single element in a compound. A single element in a compound. This is the only one that has two compounds as reactant, two compounds as product. This is what we call like swap a date. A and B came to the prom together, C and D came to the prom together, but A went home with D, B went home with C. The only thing is, you have to, when you swap, it has to be a metal plus a nonmetal or polyatomic ion that has an anionic charge that will try to gain electron. The other thing to notice that when a hydroxide combines with hydrogen, you get water, which is just hydrogen and hydroxide. So this is actually an acid-base neutralization right here. We have all acid-base neutralizations are double replacement. We have magnesium hydroxide, a base, sulfuric acid, gives you magnesium sulfate, and water. We have neutralized this acid. That's pretty neat. We only have one more type, and this last type is usually the easiest to understand or to recognize because it's always the same. The products are always the same. We have some kind of hydrocarbon, which is a fuel. Some kind of fuel. It is hydrogen and carbon, sometimes oxygen, but some kind of hydrocarbon. This right here is the formula for table sugar. Plus oxygen. We all know that you need oxygen to have combustion. And complete combustion, you will get carbon dioxide plus water. So anytime you have a fuel and it is burned with oxygen, so you need some kind of activation energy, you will get carbon dioxide and water, and heat will also be given off, heat. Now you can say, I've never seen water when I burn things. Well, that's because the boiling point of water is 100 degrees, and when you burn something, it's usually hotter than that. So the water is usually in a gas state. And so is the carbon dioxide. You can see this if you've ever noticed after you shut down your car, sometimes it drips water, and you wonder, where does that water come from? Well, that is the H2O in a gas form in your exhaust system, and you turn off the car, it's still in your exhaust system cools, that water condenses, and then it drips out. So that is not actually in your engine, that is just part of your exhaust, if you've ever wondered where that's coming from. So today, so far we have reviewed synthesis, decomposition, single replacement, double replacement, and combustion. So now it's your turn. Try to determine what type of reaction this is. And here we go. It is a decomposition. There is one reactant. Here's another one. This one is synthesis. There is one product. Let's try another one. This one is double replacement. It is hard to tell. It looks complicated, but it's the easiest one because there's two compounds in the reactants and two compounds, binary compounds, in the products. Here's another one. This one is combustion. It is a hydrocarbon, in this case it's propane, in the presence of oxygen, and it results in water plus carbon dioxide. Here's another one. This one is single replacement, and this is metal-metal. Now you notice that the metal is by itself and replaces hydrogen. Hydrogen, once again, can be very flexible because of that one valence electron, and it can be in the metal spot, but it's replaced by a more active metal and it ends up being hydrogen gas. This is an acid plus a metal. That's why metals all react with acid, almost all of them. Some of them do not react with acid because almost all of them are more reactive than the hydrogen gas. So that is single replacement. So once again, you need to be able to recognize synthesis, decomposition, single replacement, double replacement, and combustion reaction using your reference table. Thank you very much.